So you're welcome to New Track Mathematics class. In today's discussion, we're going to look at the modular arithmetics. The modular arithmetic, we're going to look at the introduction in this video, and subsequent videos, we're going to look at the modular addition and subtraction, then the modular multiplication. And the link will be found here so that you can easily access such video. If you haven't subscribed to our channel, I want you to subscribe so as to get more of our videos, and do give this video a thumbs up and a like so that you can get a subsequent edition of our videos. We are going to also look at the introduction into modular arithmetic. Modular arithmetic is an interesting part of mathematics. And at the end of this discourse, if you are not able to get the answer to this question, we'll be bringing the modular multiplication, addition, and subtraction series, which you are going to get an answer to this question. So if you want to learn how to solve questions like this, which is frequent in most of your exams, you need to keep watching. Now, the next thing we want to look at in general is what modular arithmetic is. Now, most people hardly understand what modular arithmetic is. Most of the time, they keep asking themselves, what is modular arithmetic? Now, modular arithmetic has to do with the arrangement of numbers in such a way that the occurrence of such numbers are being put into cognizant. Now, in many parts of the world, some activities like the market days, clock tuning, shift duty, weekly activities, their church days, anniversaries are all carried out in circle. And these activities are held every specific period number of what? Of periods. Now, for instance, let's look at the market day. Most of us in our locality have some days in which we go for markets. Let's say 4 days or every week. So in every 7 days, they used to go to market for 4 days, some certain 4 days. But then the question now is, now if for example we have A, B, C, D, and this denotes the 4 market day, which is most popular in some part of Nigeria, which is the east, Eke, Ore, Afo, and Nkwo is in place, and they are represented by A, B, C, D. Then the fifth day will correspond to A, which in which the market day originally started. Now, I said modular arithmetic has to do with what? With consistency, the movement of numbers. Now, let us represent this in a circle for a better understanding. Now, if we check out this circle, you come to understand something about this circle. Now, we've looked at this market day in terms of circle. We represented A with the 1, B with the 2, 3 with with C with the 3, and D with the 4. Now, if we represent each of these day with what? With code 0, 1, 2, and 3. Now, you come to notice that if A represents the first market day, the 1, if we count it 4 uh, count 4 times, we'll find out that the next time the market will be holding will still fall down in the fifth what? On the fifth day. So if we look at that very well, we can use this to bring up a what? A table. And when we bring out a table, we'll look at the code, the number code for each of these market day, A, B, C, and what? And D. Now let's represent this in a code. If we represent this in a code, we are going to see how this can be represented. Now let's assume that 0 is the code for A, just as we have said. B is 1, C is D, and C is 2, and D is what? Is 3. Now the days of the week. Let's now look at the days of the week. So if we now say Sunday is starting with 0, which is the AK, the A. Tuesday is 1, Wednesday is 2, Thursday is C, Friday is 4, Thursday is 4, Friday is 5, and Saturday is 6. So if we arrange this in such a way that we represent each of them according to the market and the what and the number code, this table will now simplify everything. Now pay attention to this table as we'll be explaining this table. Now this is week 1 and this represents the market day, the first day of the market. This is the second, this is the third, this is the fourth. It begins again A, B, C, and what? And D. The next week, it begins A, B, C, and D. A, B, C, and D the third week. Now, each of these market day starts with what? With a code. Once you understand this table, then you will be able to understand what modular arithmetic is all about. Now, 6 days. Let's look at 6 days after market A. This is market A. We want to look at 6 days after market A. On which day will the market fall? Market A is represented with the code 0. So 6 days after market A, what market will be on that day? 1, 2, 3, 4, 5, and what? And 6. Now you notice that that will be what? Market C. And the code for market C is 2. The code for market A is what? Is 0. So the circle, the number of days that will correspond for us to get to market C is what? Is 0, is 6 days. So if we say 0 plus 6, that will correspond to what? That will correspond to code 2, which is the market day C. Now, do you take that? Now, let's consider another scenario. Let's consider 10 days after market D. 10 days after market D will give us market B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you notice it? That will give us market B. And the code for market B is what? Is 1. So if we look at 10 days after market D will give us what? B, which is what? Which is 3 plus 10. That will correspond to what? That will correspond to 1. And 1, that 1 is the market day for what? For B. So 10 days from market D, which is what? From market D, which is what? Which is 3. So if we say 3 plus 10 will correspond to what? It will correspond to market what? It will correspond to this market B, which is what? Which is 1. Same thing goes with this. Market A, when we count 6 days from market A, will correspond to what? Will correspond to what? To market C, which is what? Which is 2. Now, this is how we go about looking at modular arithmetic. Now, let's explain this table more better. Now, having considered that scenario, the next thing we want to look at now is let's consider the 4 days market day now. Let's go back to the 4 days market day. Remember, market A started with what? With code 0. And when we counted 6 days, it should give us 6 days from then. 0 plus 6 will give us 6, right? So if we divide 6 by 4, that will give us what? It will correspond to what? It will be 1, remainder what? Remainder 2. Now, in modular arithmetic, 2 is very, very important. So therefore, if we have market day 0 plus 6 days, it will give us what? 2, correspond to 2. And if you go back very well and find out, you find out that it truly corresponds to what? Corresponds to 2. So that is how we go about looking for modular arithmetic. So if we count from market A, 6 days from market A will correspond to what is equivalent to what? 2. Now, another way of putting this, if we are looking for this, is what? 0 plus 6 days. That will give us equal to what? 6. Now, if we multiply 1 times 4, it will give us 6. 4 plus 2 will give us what? 6. So that means the value is what? 6. So 0 plus 2 is equivalent to what? 2, which is what? Which is the remainder for this. So from this example now, the modulus of 4, which is the 4 days, is 6 equal to 2 module what? Module 4. Now we are going to consider the other scenario. Remember, we talk about the 10-day scenario. Now, if we consider the 10-day scenario, considering the 10-day scenario with what, which with the market, which comes every 4 days, 3 plus 10 will give us what? 13. So 13 divided by the 4 days will give us 3 remainder what? 1. And if you notice, it falls on the what? On the on what? On 1, on market day P, which is what? Which is 1. So you see how it rhymes. So we are going to look at that. And another way we do that is 3 plus 10 is equal to 13. So if 3 times 4 will give us 12, plus 1 will be 13, because the remainder is 1. So from this expression now, we can say our 10 is equal to 1 module what? Module 4. So that will now bring us into what? Into our market day. Now, what if we decide to count instead of clockwise, we decide to count anti-clockwise? That is when we will now come about the negative modular. So when we come about the negative modular, we'll come to see that, so if we count anti-clockwise 5 days from our market A, that will denote 0. Remember the code. So we will now arrive at market D, which is denoted by 3. Now in mathematics, that counting anti-clockwise signifies negativity. So that will be like counting back 5 times. So we'll have 0 minus 5, and that will give us what? The market D, which is represented by the code 3, right? The market A is code A. If we count negatively 5 times, we'll get code 3. But in mathematics, 0 minus 5 is negative 5. So if we look at minus 5, we can represent minus 5 with minus 8 plus 3. So if we take it back to a modular time, we can have our minus 2 times 4 will give us minus 6, plus 3 will give us what? Minus 5. Minus 8, that will give us minus 8. Minus 2 times 4 will give us minus 8. So when we add 3 to it, it will give us minus 5, because minus 8 plus 3 is minus 5. Now you can see now, therefore, that 0 minus 3 is equivalent, minus 5 is equivalent to what? It's equivalent to 3. So we can take note of that 3 because it's going to be the remainder. Remember, in modular arithmetic, the remainder is very, very important. And that is a point I want you to note as we conclude this discussion. So take interest. Our interest should be centered on the remainder after every division. Now let's consider these 3 questions. These 2 questions, we are going to consider these 2 questions, and we're going to see how we'll find answers to this question on the board. The first question says we should express the number into modular numbers 8 to mod 3 and then 10 to mod 2. Then we're going to see how we'll find the solution set for x in x equal to 6 mod 12. Now let's go straight down to our class board. So if we are asked, the first question, we are asked to express these numbers into modular time. We are asked to express 8 mod 3 into modular time and 10 to mod 2. And the question B says we should find the solution set for x, where x is equal to 6 mod 12. Now let's look at the first one. We are asked to express them in modular number. Now to express them in modular number, we have the number 8 to mod what? 8 to mod 3. Now, if you are asked to express this number to modular times, the first thing you do is to find out if 8 can be divisible by if 8 can be divisible by 3. If 8 can be divisible by 3, 8 divided by 3 will give us what? That will give us 2, but it will have a remainder because 2 times 6 will give 3 will give us 6, but we'll have remainder what? The remainder will be what? 2. Remember, I told you that in modular arithmetic, the remainder is very, very important because the remainder forms the modular numbers. Now, let's look at that. Since we have the remainder 2, our final answer, therefore, will be what? 8 equal to what? Equal to 2, which is the remainder mod what? 2 mod 3. So this is the modular number of this expression 8 to mod what? 8 to mod 3. Now, when you are asked to express a number to modular terms, we have to go by it this way. So this stands as the what? As the remainder, which forms the basis for the modular number. Now let's look at question number 10. Number B says we should express 10 to mod 2. Now to express 10 to mod 2, we'll have to divide 10 by what? We'll have to divide 10 by 2. 10 divided by 2 will give us what? That will give us 5. Now will there be any remainder? No. Very good. So the remainder will be 0. So since the remainder is 0, our this term 10 to mod 2 in modular terms will be what? 10 equal to what? 0 mod what? 0 mod what? Mod 2. So that is the solution. That is the expression for this word, for that modular number. Now you see that solving question in modular arithmetic can be very easy, especially these less easier ones. Now let's look at the next question. The next question says we should find the solutions to what? Find the solution for x if x is equal to 6 mod what? If x is equal to 6 mod 12. Now, if we want to do that, the first thing we'll first look at, that question is asking us to find the solution set. Now, for us to find the solution set, if we are given the value x equal to what? 6 mod 12. Now, we should remember that the value x minus 6 is a multiple of what? Is a multiple of 12 because 6 is a multiple of 12. So if x minus 6, if 6 is a multiple of 12, x minus 6 will be a multiple of 12. So that means any number within this range, x minus 6 equal to what? 12 raised to 12 times n, where our n will be set of number from 0, 1, 2, 3, and on and on. Now, if we want to find the solution set of number, all we need to do is to input all these value as n into this value. Then we'll see what x will be for each of these sets of number. Now, let's look at the first one. The first one, let's assume that our n is equal to 0. If our n is equal to 0, then our x minus 6 will be equal to what? 12 times what? 12 times 0. So if 12 times 0 will give us what? 0. So in this regard, our x will be equal to what? 6 will cross over this time to give us what? Minus 6 will cross over to give us what? 6. So that means the set of value for n equal to 0 is what? Is 6. Now let's look at the next one. If n is equal to 1, then our x minus 6 will be equal to 12 times what? Times 1. And that will give us what expression? 12 times 1 is 12. If 6 cross over here to this way, it becomes plus 6. So our x will be equal to what? 12 plus 6. That will be equal to what? That will be equal to 18. Good. Now, the next one we'll have is if our n is equal to what? 2. If our n is equal to 2, then we'll have our x minus 6 to be equal to what? 12 times what? 12 times 2. And 12 times 2 will give us 24. So that will give us what? X minus 6 equal to what? 24. Now, if minus 6 crosses over to this place, it becomes plus 6. Now, x will now be 24 plus 6. In this regard, our x will be equal to what? 30. Now, if we make our n to be equal to what? 3, which is the final set of number, we'll have our x minus 6 to be equal to what? 12 times what? Times 3. 12 times 3 will have our x minus 6 to be equal to what? 12 times 3 is what? 36. So if 6 crosses over here, it becomes plus 6. So 36 plus 6, our x will be equal to what? 42. So we see our set of number, therefore, for x remains what? 6, 18, 30, 42, and continue as long as we are not limited in the numbers we input in that value. So the solution set for x equal to 6 modulo 12 is 6, 18, 30, and what? And 30 and 42. So you see, solving question on modulation is very, very easy. Arithmetic modular is very easy, and in most exams, you do see questions like this. Take out your time and watch this video once more. You are going to understand in-depthly what the solution is all about. And I want to thank you so much for watching this video from the beginning to the end. This lesson, in the next lesson, we are going to consider the addition and subtraction of modular number. Make sure you don't miss that video. Hit the subscribe button so that once that video is published, you will be the first to get notified. And don't forget to hit the notification button. Thanks so much for watching, and I look forward to seeing you watch our subsequent